Hello guys, this is Miss Scott, and today we are going to start chapter 10, which is everything you ever wanted to know about circles. Before we get into that, here's your bad joke. Did you hear about the buffalo that lived for 200 years? Well, it just celebrated its bicentennial. All right, well, let's jump into these notes here. Today we're going to talk about properties of tangents and how we can use those to set up equations and find missing lengths. So your essential question is, how can you verify that a segment is a tangent to a circle? All right, and we're going to talk about what a tangent is in one of these vocab words down below. I am not going to sit here and work through all of these. What I want you to do is actually stop what you're doing right now, okay? So stop the video. If you have not done the vocab, there will be a link somewhere on this page. I will link you to a Quizlet, and in that Quizlet it's going to have all the vocab that you need in order to continue. So do not continue unless you have the vocab done. Otherwise this lesson will be very confusing. So click the link, get the vocab, then come back and see me to finish up these notes. Alright, so you have your vocab now. Let's take a look at our first theorem. Alright, so here we're going to talk about segments, lines, and rays. So in a plane, a segment, line, or ray is tangent to a circle if and only if it is perpendicular to a radius of the circle at its endpoint on the circle. That's kind of confusing, and I think it might help if we draw a picture. So I'm going to draw a circle here. So I've got this circle, and if I draw in, let's put the center here, call that point C, and this here would be the radius. So I can call that R for radius. And if you have a segment, a line, or a ray, I'm actually going to do a line. So let's put some arrows on the end of this, and we'll do that in red. If I have a line here, and that line is tangent to the radius right at that point, it turns out that that's only true that it's tangent at that radius if this is a perpendicular. Okay, so it makes a right angle there. And if it makes a right angle, we can use all those fun facts about right triangles to solve for missing lengths and set up equations. All right, so let's just dive a little bit more into what this word tangent means. Tangent just means things touch at one point and one point only. And we're going to use this diagram below to find the number of common tangents that the pairs of circles have. All right, so if we look here at, zoom in a little bit here, actually forget it. If we look at circles A and B, I'm just going to draw those two circles separately. So we got circle A right here, there's A, and then we've got circle B right here, so a little bit smaller, we got circle B. And we're going to figure out how many lines we can draw that are tangent to both of those at the same time. All right, so let's give this a try. So I see one that's pretty clear. It's this line right smack down the middle. That would be tangent at this point where those circles touch. There's also a tangent that goes right about here. Actually, move that up a little bit. So it's just barely touching circle A at the top here and circle B at its top here. So there would be another common tangent. It's tangent to both. And then we'd have another one, very similar to the one above, that is just going to touch A at the bottom here and B at the bottom here. And I encourage you to try this, but I don't think there's any of the other lines that are going to be tangent to both A and B at the same time. So in this case, I think there are just 3 common tangents. All right, let's try circle C and D. So we got circle C, and inside of it, we have circle D. And circle D is inside here. All right, so that's these right here on our picture. Okay, so if we try drawing in some common tangents, well, I only see one place we can do this. So on the bottom here, where they touch together, that's the only place you can draw a tangent line. Yeah, I don't think there's anywhere else that'll work. So this one, it's just got one tangent line. All right, and lastly, we will look at circles B and C. All right, so we got circle B right here, and then circle C is the large green one on the right. So then there's circle C. All right, now let's see, a common tangent. Well, kind of like in number 1 here, I see one that goes on the top of both circles and is touching B at the top and C at the top here. And I also see one below. All right, I'm going to move that down again. So it's touching at the bottom of circle B and towards the bottom of circle C. And those are the 2 that are pretty clear to see that are common to both circles. But then there's also kind of this tricky one here that goes tangent to like the upper left of circle C and the lower right of circle B. And then if we do that this way, and I'm going to move that over a little bit so that it's touching here at circle B and here at circle C, this one actually does have 4 common tangents. So instead of just having that one in the middle, there's 2 common tangents in the middle, and we end up with 4 common tangents. All right, and unless the circles are the same exact side and sitting on top of each other, 4 is the most that you're going to be able to get when you're looking at common tangents for 2 circles. Okay, if you start to add more circles, different things can happen. All right, so let's take a look at now getting into a little bit more algebraic problems. All right, so we've got on our next example here, segment AB. So this segment AB right here is tangent, a tangent of circle C, and we're going to use that information to find the radius R right here. All right, well, notice that this is a tangent, so it makes a right angle here, and we can actually use the Pythagorean theorem to set up an equation to find what the radius is. So this is my hypotenuse here, and it turns out this hypotenuse is R, the radius, plus this length of 8. So this whole segment from C to A, the hypotenuse is R plus 8. So if we fill into the Pythagorean theorem, we're going to say the R squared plus 12 squared equals R plus 8 squared. All right, and R squared we're just going to leave as that. 12 squared is 144. And you have to be careful over here with R plus 8. That is not R plus 64. It means you have R plus 8 times R plus 8. So we are going to need to FOIL that out. So we've got R times R gives us R squared. And then we'd have R times 8 and 8 times R. So we'd have 8R twice, which would give us 16R. And then lastly, we'd have 8 times 8, which would give us 64. So a little bit of foiling there. And on the other side, we still have R squared plus 144. All right, so let's try to get all of the R's on one side and all the constants on the other. You might be looking at this and saying, oh no, R squareds, but hey, if we subtract that R squared from both sides, what's going to happen is that these are going to cancel and you won't even have to worry about them. All right, let's also subtract this 64 from both sides to get all the constants to one side here. All right, so 64, if we take that away from 144, leaves us with 80. On the right-hand side, we just have 16r. And if we divide both sides by 16, we end up with getting 5 as our radius. All right, it's kind of a cool example there using a little bit of trigonometry, Pythagorean theorem problem. All right, so our next example, we're going to need to use the area of the circle formula. I would encourage you to star this, highlight this, put some arrows around it. This is a very important formula. You've probably seen it before. Area equals pi r squared. That's going to be useful to us throughout this entire chapter, so make it stand out here. We're going to use this quite a bit. All right, so let's set that up. We now know our radius from this circle in number 4 is 5. So we're going to plug in area equals pi times 5 squared. And if you have a calculator handy, you can just plug it right into the calculator like that. You could also simplify it a little bit further before you plug it in. 5 squared is 25, so this would be 25 pi. And 25 pi, if you plug that in, 25 times 3.14 is about 78.5. And this would be units squared. It didn't tell me if this was inches or feet or centimeters, so I'll just say units squared. Okay, let's look at one last theorem here, and we'll finish up with an algebra problem. Okay, so tangent segments tangent segments from a common external point are congruent, which is a lot of times the case when we're looking at theorems. We always seem to be saying things are congruent in geometry. All right, so again, say we've got a circle, and we'll call the center C again, kind of the standard. And we've got 2 points on here. I'm going to call this A and this one down here B. And if you put some point P somewhere outside of the circle, it turns out that if you draw a segment from A to P and from B to P, these two are congruent. So we could say AP equals BP. So those two segments are congruent, so their lengths are equal. All right, and that's only true if those points A and B are tangent, so just be careful with that. All right, so in number 5, our last example, it says JK and JM are tangents of circle L. Find the length of segment JK. Well, notice that K is an M. Those points are both on the circle, and they're telling us JK and JM are tangents. So what happens is that 3x has to be equal to x plus 12. And in fact, that's how we are going to set this up. 3x equals x plus 12. And we can go ahead and subtract that x from both sides. We end up with 2x equals 12. And if we divide by 2, we get x equals 6. All right, so they actually aren't saying find the value of x. They want us to find the length of JK. Well, JK is 3x, so we have one more step just to plug in that value of x. So 3 times 6 gives us a length of 18. All right, so I hope you guys enjoyed the video today. Again, make sure you subscribe to my channel if you haven't already, and leave any questions or comments down below. Or if you are a student that has the privilege of being at Central High School, well, you can come find me and ask me in person. All right, take care, guys. We will see you next time.